Welcome back to this session with the title Decarbonizing Construction Supply Chain. Current technologies can halve emissions today with over 70% of carbon reductions by 2030 possible if coordinated efforts are put in. To achieve that, digitalization is a critical enabler, of course, as well as scenario analysis and stakeholder collaboration. This next session will cover pathways to decarbonizing building and transport infrastructure supply chains and achieving near zero emissions by 2045. This important topic and the way there will be presented to us by a postdoctoral researcher at Chalmers University of Technology, Ida Karlsson.
Thank you. It was a nice reset. Great to be here. It feels like a luxury to take the stage after Theo had his amazing keynote. I got really inspired to do new things. I hope you got too. So work to do. I'm going to, in one way, broaden the perspective and looking at climate change, carbon emissions, what can we do? And maybe also in one sense narrow it then. But to start with, globally, buildings and infrastructure stand for about 40% of global carbon emissions. That's a lot. So we really, everyone in this sector has a huge potential to make a difference if we do it together. And the emissions of the building and infrastructure can be divided into embodied carbon, which are the emissions that are associated with construction materials, transport of these construction materials, and then installing them so we have a building, road, railway. And then operational carbon, which is mainly the energy used in buildings. And on a global level, the operational emissions are dominant. But the embodied carbon are catching up. So it looks like this on a global scale. But if we focus in on Sweden and the Nordics, it looks quite different. In Sweden, the emissions that come from the heating and the operational emissions, they've actually been reduced down to a third since the 1990s. And that's mainly because we worked quite a lot with building energy efficient buildings, but we also transitioned our entire heating system from individual oil-based heaters to heat pumps or district heating systems, mainly powered by biofuels. So in Sweden, the embodied carbon is actually a majority of the emissions linked to the building sector. And that's where I've really dug deep and focused my research in the last 7 years I've worked with this. And what we can see is that it really is concrete and other cement-based products, steel, and diesel use in material transports as well as in the construction process, which are the main culprits. And maybe those are the ones that we should start to target first. And these three together actually combined are responsible for about 70% of the emissions associated with building construction. And we see from all the research and all the work that has been done that there are large solutions, there's so many measures that we can take to reduce these emissions. But we also face a lot of barriers. What we can see is that there's a large difference between the potential that we see for carbon emission reductions and the actual implementation. One thing that we see is that pilot projects, they go a long way, but there's a limited scale up across the sector. Often we do pilot projects, but then they stay being pilot projects. But we need to make that the standard, the norm, the everyday. And we also face an insufficient competence and resources all along the value chain. From the client side, the ones who are doing the procurement, to the designers, architects, everyone there, to the contractors and subcontractors, to the material suppliers, everyone along the chain need to understand and see their role, and we're not really there. We have specialists that know a lot, but in order to actually being able to reach the potential that we see, we all need to be on board on this, and we can be. But for that to happen, carbon reduction needs to be a part of the competitiveness. It needs to be a part of the business deal, not just come on the sidelines. And in that, we actually see a lack of both sharp and predictable procurement requirements that are linking carbon performance to the deals that we make and to the procurement contracts and the procurement contractual firms. And we also see that we don't have the carbon assessment and the mitigation or different solutions integrated into the systems and the routines and the processes that we work with in the everyday life. And there's a lack of data for both monitoring and follow-up. We do it, maybe sometimes we do it at least on a project level. We do carbon calculations, but they often come after the project is completed. But we also don't really follow up on an organizational level. We don't have the data enough to do that. We have quite good control about our own emissions within the scope 1, scope 2, but everything that has to do with the value chain, the supply chain value chain, we're really working on gathering that data. So what I've been working on together with my colleagues, and colleagues all along the value chain, I will say, my work has been about co-developing knowledge together with industry stakeholders. So I've looked at mapping, describing, and quantifying different types of reduction measures and seeing how these can contribute to reducing emissions, not just now, but what can we do over time, all the way until we are meant to be at net zero emissions by 2045 in Sweden. How can this look like? And I've used a lot of different information and a lot of different workshops and dialogues with stakeholders in order to kind of set how can this pathway or this road look like. And for that, I've developed these decarbonization pathways and am now working quite a lot over the last year, and I will continue to work on supporting large-scale implementation of carbon reduction measures. And that's one of the reasons why I'm here. It's one of the reasons I'm now looking at how can we integrate this into the softwares, into the tools that we're now using. And really what we see opportunities for carbon reduction that exist all along the construction supply chain. All the way from we have a demand that we want to fulfill in the early planning stage, through the design stages, to the construction site and the logistics, and also to the materials that we use. And these, I've just gathered some of these that we see. And it's about optimizing existing structures, which I think Theo was already talking about this. Maybe moving forward, we won't see as much new construction, but we're really digging deep into how can we work better with the built environment that we have, the existing built environment. How can we optimize that? Can we work on repurposing, converting? Now when we are working more from home, we're seeing more and more vacancies in offices. How can we then use those built buildings better in a different way? And then when we do build, or when we do large projects, can we work more with resource-efficient designs, form factors, bandwidth, all of those things to optimize? Can we work on more structural optimization, looking at each element and seeing how can we create the same function with less material? And then how can we work with large-scale reuse and also in prefabrication? And then in the next stage, how can we work with the actual transports and the construction process? Can we work with fuel substitution, working more and more towards electrified sites? And then, of course, optimizing here, logistics, the setup of equipment that we use, how we use it, the same with the transport distance and the modes of transport. And in the actual production, the material production, there's the same thing here. We can substitute the fuel that we use, going more towards fossil fuels. We can electrify industrial processes. We can also, in some instances, we actually might even have to work on carbon capture, for example, in cement production, where quite large parts of the emissions come from the actual chemical process. We can also work on material substitution, increasing recycling rates, having more circular resource flows. And the same thing with all the masses that we have in the building and construction sector. How can we circular them? And if we combine all of these, we see that there really is, by taking comprehensive measures across the board, we can reduce emissions dramatically. And this is also based on what could actually be feasible, not just in a theoretical sort of, this could maybe be. But if we all do our part and say that we do what we say we can do, this is what it could look like. And that means a potential of over 70% reduction by 2030 and close to zero emissions by 2045. But of course, there's a lot for us to take us there. So how can we kind of dig it down a bit? One thing that I wanted to just highlight is a cost-effective implementation by focusing on resource efficiency. I want to take a case study that I've done, exemplified it with the construction of a concrete frame multifamily building. And in this graph here, I've only looked at, okay, if we do measures in the sort of material production, the primary material production, how can that look like? And then I combine that with what if we do what we can do with the design, at the design stage, in the structure, doing optimizations, and working with the material composition. And then we can see that, especially in the short to medium term, there's a large difference in the potential if we work with measures along the value chain. But what we can also see is that some of these more measures that require quite heavy investments, for example, electrifying industrial processes in steel production, in cement production, or doing carbon capture in the cement production. The reliance on those in the longer term actually reduces, which means that we get a more cost-effective implementation. And we also use less material, which means we can also reduce the cost in that way. Another sort of key result that I really want to bring forward is moving away from talking about concrete versus wood. That shouldn't be a question at all. It should more be about how can we combine material to get the best function and utilize the properties of each material in combination to get the best product. And I just wanted to highlight that there is potential to reduce emissions regardless of what kind of, like structure or frame that you're working with. Here is the same concrete frame multifamily building, and there's also an equivalent functional building, the same function, with a wood frame. And we see in the reference case, if we do a simplistic analysis, the wood frame has a lower carbon emission. But then we haven't made any sort of measures to reduce the emissions. If we do that, based on what was available 2020, we can see that they're almost kind of equal. And if we work more on reducing, like now 2025, we can get an equal output. And that might look like, well, then you are sort of comparing concrete versus wood. No, that's not what I'm trying to do. What I'm trying to say is that regardless of which materials we use, which solutions, which frame, we can do a lot to reduce emissions. And with that, I want to really get into how can digitalization be an enabler in this? And I'm not an expert in this. So I'm pretty sure that a lot of you out there are more experts in this than I am. But what I've tried to think what can be helpful, where could digitalization support the decarbonization? And also make use of a lot of other smart people and other recent reports. And what I really think is that we need to, it's bridging the data gap makes it possible for us to make informed long-term decision-making and creating these continuous information flows so we know why we're making certain decisions. and we know what results they will have. And in generally, there's a general lack of data on emissions and biodiversity impacts of construction, and lack of widespread knowledge about sustainable solutions. And that's why we often try to seek these silver bullet solutions, that one solution that will solve it all. They don't exist. It's a combination. And then addressing gaps is crucial for making that informed decision making. And I really like Theo's approach of actually working this with platforms and enabling data sharing across systems. And also sharing both data and research findings and results from actual projects, and research results, so that we can support each other in this journey. And by that, then facilitating a large-scale adoption of circular and sustainable practices. And another thing there is, how can we better use BIM to make more accurate and cost-effective carbon assessments? Because now there's starting to be more and more requirements that we do carbon assessments, but we don't fully utilize BIM models in this. Because either the data is missing, or it's not in a non-standardized way that's not compatible. And actually, OECD found in a recent survey that the main challenge for implementing policy linked to carbon calculations and carbon assessments is the workload placed on applicants when calculating. That really shouldn't have to be the case with all the systems that we have in place that can support us in that. So by creating this, addressing the data gap and ensuring that the data that we share, the flows, also include the CO2, the carbon footprint, and the resources that we use. We can streamline assessments, we can reduce workflows, and we can enhance the data accuracy. The accuracy of data collection, which can also support all our companies when we now have to do all the sustainability reporting. So I really see digitalization as a very good enabler towards decarbonization by optimizing resource use from a systems perspective, to visualize and make data available about the resources and the emissions throughout the construction process, and to enabling the sharing of resources as well. And of course, the traceability that can help us throughout the life cycle of buildings. And by that, enabling both new business models and value chain. And if I go back to this picture here with all the different, I can pretty much pinpoint that almost all of these can be supported by more digitalized solutions. So it really is an enabler toward decarbonization by improving emissions efficiency, we can reducing scope-free emissions, and we can enhance circularity. And I wanted to just finally say one thing that I really see a huge potential going forward is to use digital tools in early design to use less materials, thereby reducing CO2 and reducing cost. Here's just one example. With a recent tool that's been developed that can make early calculations comparing different systems, where it's at that stage where you might even you decide the system that you're going to build with, but you also decide maybe what type of building, what width are you, what geometry do you have. And this can make that comparison. And it can also not just put in generic data, but also put in specific supplier data so that you are actually making those informed decisions, because it might vary very much based on which supplier you're using and what type of carbon performance do they have compared to the generic data. And then you can make the decisions about, okay, for this particular building, what's the best frame type that we can use? Which is not generic. It's based on the number of floors, the geometry that you have, all of these things. And there we can really utilize the digital solutions and then take that data that we get and continue it on throughout the chain. And some success factors that I see to bring forward, firstly, is for really a successful decarbonization, is to focus on the resource hierarchy, as this is called, working on the existing building environment that we already have, and seeing how we can work best with that before we go to constructing new buildings. And creating conditions for close collaborations across the supply chain. Because then we can really utilize each other's skills in the best possible way. And align procurement contractual forms to support this. And build engagement throughout the project team. I really believe in gamification, and I also think that digitalization can support this gamification on actually making what can you do in your role to reduce emissions. And dare to question all norms. There's a lot of old norms out there, and we actually build with more material today for the same function than we did 30, 40 years ago. Is that really necessary? Should we do that? Should we have to build with more material, more cement in the concrete, more emissions? When we have all that tools available to do better. So resource efficiency and circularity at every stage, and have a systematic processes and digitization in that. And combining metrics. Money always talks, so put money on CO2. It will happen. It's already happening in the EU ETS, in the trading scheme. It will come through to the construction materials as well. And expect some cost shifts here, but having cost neutrality as a goal. So it's possible to reduce emissions, halve emissions already, with already available measures and technologies. And we can reduce emissions drastically going forward. But we need to collaborate along the value chain in order to do this. And align policy measures, strategies, and systems to do it. Thank you.
You mentioned gamification.
Yes.
What kind of gamification features would you prefer to see?
I would prefer to see that you can, for example, for architects and engineers, you can compete on how low you can go. How low can you go in emissions within what you can do with your role?
Gain points for smart decisions?
Yeah. And we already see it in some construction sites. They've already started doing it with all the drivers of construction equipment. They're not pushing them, using digitalized data to seeing how low can you go in reducing how much fuel you use for the same task.
Just for competition alone they do it, just for fun, or are there other... Do you know if there are other factors at play as well? Is that linked to performance, or to pay, or bonuses, or anything? It's just... In
those ones, it's just for fun. But I've also seen, linking incentives to it. That makes the game even better.
Does? So. Yeah, okay, cool. Okay, so on another note then, other than gamification features, what software, what platform, what solutions would you like to see in order to bring this, to accelerate this development?
I'd like to see a way to really visualize the carbon emissions from a very early stage, so we can get people involved that might not have the knowledge, might not even have the engagement, but getting them to understand what different choices, what difference they can make. And then it always helps if you put, money to it. Mm-hmm. So pinpointing the money as well, but also visualizing makes it so much easier to actually understand what different decisions make. And I'm talking, for example, I meet a lot of municipalities when they build up. They might not have the understanding or the knowledge, but when you visualize it, and you actually make it quite easy to see, you can make that decision, you can make that decision, and this is the implications. It makes it a lot easier.
Can you give us just a really short image of how such a visualization would look?
I mean, just the
numbers
one. I think it can be, but numbers, they can talk, but
doesn't really evoke your emotions.
No, it doesn't. I think what really evokes your emotions if you can see it in front of you. And that's why the BIM models are so good, because you can visualize it. And then you can make a graphical as well, so you see the difference. And that's what I think they did so well in those comparison, the different frame systems, is you see them in front of you, but you also then see what happens if you make certain decisions.
Right. Okay, cool. Thank you so much for your research, of course, for being here, for spreading the knowledge on these important topics, and also perhaps inspiring more of us to collaborate even more than in order to reach that 70% goal in 2030. It's not that far ahead. Thank you so much, Ida.
No.
Thank you.
Thank you.